Hello, I'm Clement, and in this presentation, I will be sharing our research paper titled Crafting Interactive Circuits on Glazed Ceramic Ware. This work was done in collaboration with Han Bo, Liu Xin, Hans Tan, and Yan Xingxuan from the National University of Singapore, as well as Laura Devendorf from the University of Colorado at Boulder. In this work, we sought to expand the materiality and making of interactive systems through glazed ceramic ware. Glazed ceramic objects have been around for a long time. They are everywhere, and we still use them every day. When we looked behind the utility of these objects, we saw a rich and deep set of practices and traditions around the making of these things. Our project built on top of one specific practice within the large domain of ceramic craft. We had the opportunity to collaborate closely with the ceramics crafter and designer Hans Tan, who is also our colleague at the National University of Singapore. Hans is a Singaporean designer who is perhaps most known for his sandblasted porcelain pieces. His work is characterized by traditional Singaporean Peranakan porcelain vessels that are transformed into objects with a contemporary graphic pattern. To create these pieces, Hans developed a process called resist blasting. Resist blasting builds upon sandblasting, which is a subtractive process that removes material from a ceramic object through a high-pressure stream of abrasive particles. To create these patterns, Hans cuts the pattern on vinyl stickers and then transfers these stickers onto the glazed surface of the porcelain object. These stickers resist sandblasting and enable the sandblasting operation to selectively remove glaze from the porcelain object. After sandblasting, the object is cleaned and the stickers are removed to reveal the transformed porcelain surface. As his colleagues, we had the opportunity to observe these resist blasted objects closely, and we noticed that resist blasting not only transformed the objects visually, it also created a structure that exposed the two very different textures of a glazed ceramic object. Over here, we have a cross-section of a glazed ceramic object with a region that has been sandblasted. Sandblasting removes the top glaze layer, exposing the bare ceramic body underneath. Ceramic glaze is usually a glass-like coating that is glossy and smooth, while the unglazed ceramic usually has a rough and slightly porous texture. As we observed these different textures, we saw an opportunity to use resist blasting to define circuit patterns on ceramic objects. Essentially, we could apply conductive ink to the surface of a resist blasted object and remove excess ink from the smooth glazed surface. Ink will remain on the rough and inlaid traces created by sandblasting, and therefore such a process would enable us to define and incorporate complicated circuit patterns onto the surface of ceramic objects. As with all material explorations, adapting resist blasting to circuit fabrication was not a straightforward process, and do refer to our paper for a lot more details of this process. For now, let me walk through the circuit fabrication approach we developed with a short video. With this fabrication approach, we designed and built a series of interactive applications for the home to probe how interactive ceramic objects can participate in everyday life. The first set of applications centered on the archetype of the ceramic tile. In this instance, we built a phone rest that passively extends the touch sensing capabilities of the phone screen for people to use their phone applications without actually using the phone. We also built a temperature sensing tile and a moisture sensing tile that can be installed into the walls or floors of our kitchens and bathrooms. These fixtures can be used to detect if the stove is in use, for example, or if there is water leakage. For the second set of applications, we focused on ceramic vessels. These vessels showcase the three-dimensional nature of ceramic circuits, and to complete the system, we also developed a series of placemats that connect the ceramic ware to an external microcontroller or power supply. Over here, for example, we have a plate that monitors the movement of metal utensils on its surface, while over here, we have a plant pot that is able to detect the soil's water level. Beyond sensing, we also explored incorporating a heating element on the base of a plate to keep food warm during a meal, or even cook food. So I hope this gives you an overall understanding of the circuit fabrication approach we developed and the interactive applications that we might build with it. For the last part of this presentation, I want to focus the discussion on a growing area within HCI that is characterized by constructive research that develops from a close collaboration with craftspeople. It is worth highlighting that in many such projects, including the project we present today, collaboration describes a bidirectional, mutually benefiting relationship where craft and technical knowledge are placed on equal footing. From the start of this work, we kept our explorations centered on the ceramics workshop. We kept the tools and processes that we used within the craft, even as we brought in our expertise in physical computing and interaction design. This challenged and surprised us in many ways. To give one memorable example, we began this project with the assumption that we could wipe off excess conductive ink as a liquid after applying it. But, much to our disappointment, the conductive ink dried too quickly for that to happen. As we were discussing this issue with Hans, he introduced us to a whole selection of scraping tools that ceramic crafters already use. And scraping as a process ended up being a lot more viable to the material that we were exploring. And, just as we learned a lot from the tools and processes of ceramic craft and resist blasting, we also found ourselves contributing back to the craft. As researchers, we were interested in communicating the tacit material findings to others so that they might replicate our work. To that end, we made a series of ceramic swatches that systematically documented the qualities of resist blasting, as well as annotated the approach step by step. We also explored using computational design to create patterns that were difficult to conceive manually, yet efficient to use with resist blasting. For Hans, he shared that he had not thought about systematically documenting his approach before, nor used computational process to create patterns. These revealed new opportunities within his own practice that he had not considered before. So to close this presentation, in this work, we presented a new approach to incorporate interactive circuits onto glazed ceramic objects. We characterized and documented this approach, and built a range of interactive home applications to demonstrate how designers might use it. We also positioned our research process within the broader conversations in HCI surrounding learning from and collaborating with craftspeople. Glazed ceramic objects are all around us, and through this project, we hope to offer one way that such familiar objects can contribute to interactive system design. Thank you, and do check out our paper for more details.